Hey everybody, in this video I'm going to show you how to solve a quadratic by completing the square. Uh, Basically the idea is that you want to start the same way you do with all the other methods, which is you want to make f of x or y equal to 0 first. So I have two examples here and I'm going to go ahead and jump into the first one. So as I just mentioned a moment ago, you want to start by making the f of x into a 0. And the reason for that is, once again, that you're trying to get the x-intercepts. And in this case, we have a's, but the a's represent the, sorry, actually, I should make this f of a. The a's represent the x's or the inputs. So it doesn't matter what you call it, still represents the same thing. And you want to make it 0 because x-intercept points always have a y value of 0. Then you have a squared plus 14a minus 51. Now, you want to move the constant or the negative 51 to the other side. And the reason is so that you have space to go ahead and add an extra part to this. So this would be 51 is equal to a squared plus 14a. And the part that I want to add is going to be made up of my b number divided by 2. Now, there's a reason for this, but I will not explain that in this video. If you want to know why, I have a great link, and I'm also planning to make a video about that, so please watch out for that. But anyway, you divide your b value by 2. So 14 is my b value, divide that by 2, and then you square it. Now, because it's an equation, you have to balance both sides. So whatever you do on one side, you have to do to the other side as well. So I'm going to go to this side and do the same. So 14 divided by 2, and then squared. Okay. Now what I get from this, when I divide 14 by 2, is I get 7. When I square 7, I get 49. So now I have 49 plus 51 is equal to a squared plus 14a plus 49 here as well. Okay. Now I need to simplify the left side. So 49 plus 51 would be 100. And this is now going to be factored. So my trinomial, which is over here, that would be factored into the following. This will become a plus 7 times a plus 7. Now, there's no point in writing two of the same things. If you know something about the laws of exponents, like with x times x, you would simply write this as x squared because it's a shortcut or easier way to write it. Well, the same applies to binomials. So rather than writing 2a plus 7s, I could shortcut this and simply put one group of a plus 7 raised to the second power. And that second power represents that I have two groups of a plus 7. All right, so now I still need to solve this and figure out the value of a. So at this point, what I want to do is I want to take the square root of both sides, because only the square root can undo a power of 2. So those two are gone. And because I'm solving an equation by doing the radical, I need to put a plus minus by this radical here. Okay, that will represent that I have two possible answers. And the square root of 100 is 10. So now this becomes plus or minus 10 is equal to a plus 7. No parentheses needed. Now this 7 needs to go, so I'm going to subtract 7 on both sides. So minus 7 and minus 7. So if you're wondering, well, hang on, what do you do with this negative 7 and the plus minus 10? Do you add the 10 or do you subtract the 10? The answer is you do both, but you need to represent both actions. So I'm first going to write down that this is negative 7 plus or minus 10. And then from here, because it's plus minus 10, I need to represent both answers, one with the plus 10, the other with the minus 10. So at this point, this gets split. So one side will say that a is negative 7 plus 10, and the other side will say that a is negative 7 minus 10. And you have just one-step equations here. You literally just combine the terms and you're done. So my first one is a is equal to positive 3, my first answer. And the next one is a is equal to negative 17. And what these answers represent, again, are two x-intercepts, one located at positive 3 and the other at negative 17 along the x-axis. So there you have it. This is the first example. Completing the square does take a few steps, but it does have some advantages over other methods of finding the x-intercepts. But I'm not going to address those in this video. Let's go ahead and look at example 2. And in this example, you might notice compared to example 1 that example 2 does not have f of a or f of r, anything like that written there. What it has is a number on the right side of the equal sign. And so it's sort of calling that negative 91, hey, come over. And so we're going to go ahead and help it along. So we're going to add 91 to both sides. So again, you want to move your constant to the other side. All right, so these go away, and I have r squared minus 4r is equal to, this is going to be 98. All right, now I left a gap between the negative 4r and the equal sign because at this stage, what I need to do is add a new component, and it's going to be based on my b value, which is negative 4. You can see it right here, negative 4. I'm going to take that negative 4, and I'm going to cut it in half, and then I'm going to square it. And being that this is an equation, once again, I must do the same on the other side in order for it to remain balanced. So plus negative 4 divided by 2, and then square that. All right, now we have to just do the math. So negative 4 divided by 2 is 2. Sorry, negative 2. Negative 2 to the second power will be a positive 4. So now this becomes r squared minus 4r plus 4. And on the right side, this will be 98 plus 4. We get the same thing out of these blue guys, okay? Now, 98 plus 4 is 102. And this trinomial over here, this whole thing, this will break down into the following. This will become r minus 2 times r minus 2. When you factor that, you would get two binomials that are identical to each other. But like I said in the first example, there's no point in writing two of the same things. So if you apply the laws of exponents, we can simply stretch that out to binomials and say, well, look, I have two groups both looking the same and they're multiplying. So why not just write one of them and put a power of 2? That power of 2 indicates I have two binomials and they're each called r minus 2. And when multiplied, I get 102 as a result. So we need to find what value of r creates that scenario, that setup. So when you do the math in here, in these parentheses, and you square it, you get 102 as an answer. Okay, so we need to kick that power of 2 out of the picture so we can get at the r. So I'm going to radical, or take the square root of both sides. And, oops. Once again, remember, when you're solving and you end up doing the radical or square root on one side, you must give it a plus minus to indicate the possibility of having two answers. Okay, so the radical and the power of 2 cancel out, leaving just r minus 2. And on the right side, the square root of 102, if you were to break this into factors, let's say you divide this 102 by 2, you would get 51. Now, neither of these are perfect squares, nor can I split them any further because they are prime numbers. So for that reason, the square root of 102 is going to stay the square root of 102. And so I'm going to leave it like that and just write plus minus radical 102. Okay, now the last thing is to take this -2 and bump it over. So inverse operation, put it right there. And these cancel out, and here's my answer, everybody. It's r is equal to 2 plus a minus the square root of 102. Now, this is the end. But another way of understanding this is you could say, all right, I have two answers. Obviously, I have a plus and a minus. One answer is 2 plus radical 102, and the other answer is r is equal to 2 minus the square root of 102. Now, the square root of 102 is going to be some weird decimal number. But if you were to add that with 2, you would get a higher value or a lower value. And this would put you at a space between squares, between nice numbers like 2 and 3, or -4 and -5. You'd be somewhere in that sort of decimal zone between these nice numbers. But they would both be your x-intercepts for the parabola made by this function over here. Okay, which if you want to graph, it would be good to have in standard form. So I hope these two examples helped. Both are about completing the square. If you have any questions, please leave them in the comment section, and I'll make future videos, one of them explaining the reason for completing the square and visually what that looks like. So please watch out for that. And as always, thanks for watching. Bye-bye.